So, hi guys, I'm Rashid. So, today we are going to mainly, in my physics class, we are going to mainly concentrate on the coefficient and angle of friction. So, what is coefficient of friction? So, in my last class, I told how to prove angle of repose equals angle of friction, but at that time, there are so many concepts that I had to prove in that video, but I couldn't prove now. Today is your lucky day, so I'm going to prove angle of friction equals the tangent of angle of the coefficient of friction equals the angle tangent of angle of friction, and I'm going to show what is coefficient of friction. So the coefficient of friction is mainly defined as the ratio of frictional force to the normal reaction. Normal reaction. We go. Normal reaction. Here we go. H. Okay. So the ratio of frictional force to the normal reaction is known as the coefficient of friction. So how do we find the coefficient of friction? So now there's a law of friction. The magnitude of friction between any two bodies in contact is directly proportional to the normal reaction between them. So as you can see, F should be directly proportional. I'm gonna show you. So the magnitude of friction between any 2 points, if the magnitude of friction between any 2 points in contact is directly proportional to the normal reaction between them. So here the law is saying that F, the force of friction, will be always proportional to the normal reaction. So this is what the law is saying. The magnitude of limiting friction between any 2 points in contact is directly proportional to normal reaction between them. So this is what the law is saying. F will be directly proportional to N. So as I told you before, F will be directly proportional to N. So F equals a constant. We name it as K. Now the constant is K. Now we'll replace this K by F equals mu. Okay, so that is a coefficient of friction. F equals mu. So F equals mu of F equals mu N. Alright, so what will be the value of coefficient of friction? So from this we can say that mu equals F by N. Get it? So the coefficient of friction is defined as the ratio of the force of friction by to the normal reaction, and in this definition, the ratio of frictional force to the normal reaction. As you can see, the ratio of frictional force to the normal reaction is known as the coefficient of friction. Now next we are going to prove how the coefficient of friction is equal to the tangent of the angle of friction. And now I'm going to start off with the figure. So here we have a table. Okay, it's not we're going to draw doodling. I'm just going to doodle a table right now. So this is a table. Here we go. Okay, and we have an object of mass m on the table. Okay, so this is the object of mass m on the table center, and the force of friction is opposing the motion of the object. Now the pulling force is towards this side. Okay, this is the pulling force. This P is the pulling force. So always the force of friction will be opposing the pulling force. The force of friction will be towards this side. Okay, so this will be the force of friction. All right, so the pulling force is this side and the force of friction is towards this side, so opposing forces. Now the angle of friction, as I told you in the earlier classes, in the earlier class, that the angle of friction is the angle made by the limiting friction on the normal reaction. So this is a normal reaction perpendicular to the surface of contact of the object, and this is the force of friction. So this is the angle of friction. As I told you in earlier class, this is the theta will be equal to the angle of friction. That is okay, that is theta. Okay, so theta. So I'm just gonna draw, I'm just gonna make a imaginary square around it like this, you know, just looks like a rectangle, more like a rectangle. So this is I'm just gonna, no, this is imaginary, this does not exist. Okay, this is imaginary. So what I'm going to do, this, as I told you, theta is the angle of friction and P is the pulling force, and sorry, I almost forgot, this mg comes right here. That is the weight of the object, mg, the force of friction we have here, and mg we have here. So we got all the stuff. Now we're gonna prove that f the angle of friction equals the coefficient of friction equals the tangent of the angle of friction. So as you all know, the opposing friction will be equals, opposing friction is F. Okay, the friction acting on the object is F. This line is named as F. So as it's a rectangle, so this will be also named as F. I'll just magnify this so that you can understand. So we have the object right here. Okay, I'm just magnifying, okay, so that you can understand. The object table is right below it. I'm not going to show that because that's not necessary. So this is the normal reaction acting on the object perpendicular to the surface. I'm so sorry if I didn't draw. It's perpendicular. It's perpendicular, right? It's perpendicular to the object. So this is N. Okay. So the force of this is so the pulling force is towards this side. So P is the pulling force, and the force of friction will be opposing the pulling force, obviously, and this will be F. The whole line is called F. And I told you that this is the angle of friction, that is theta. Alright, so I just drew an imaginary rectangle right here. Okay, this is the imaginary rectangle. So if this is F, opposite sides of a rectangle are equal, so therefore this will be also equal to F. Alright, I'm going to name this the rectangle as A, B, C, and D. Okay, this is the rectangle. So now I'm going to take this rectangle right here, A, B, C. This rectangle. Again, if I'm going to magnify the rectangle. So I'm just going to magnify the rectangle right here. Sorry, magnify the triangle. So magnify the triangle. Okay, this is the angle of friction. The magnifying. So this is F, as I told you in the previous one. This was, I'm just going to show. This is F. This was F. This was the the rectangle. This is the angle of friction. This is N. This is the pulling force. I don't want to repeat it again. So the pulling force is the normal reaction perpendicular to the object. This is the force of friction. Okay, I hope it's clear. And now this is N will be here. Okay, you understood? I hope you understood. Now if you apply the trigonometric identity over here, so the trigonometric identity, I'm going to apply tan theta. Tan theta, what is tan theta? Opposite by adjacent side, so that will be f by, so, and I forgot to name that. This is A, this is B, and this is C. Okay, so tan theta equals f by n, opposite by adjacent, opposite by adjacent, opposite by adjacent. So tan theta equals f by n, but f by n, the previous one I told you that the coefficient of friction equals f by n. I told you, right? Coefficient of friction equals f by n. Remember, we proved that coefficient of mu equals f by n. So therefore we can write that tan theta equals mu. So we proved that the coefficient of friction equals the tangent of the angle of friction. Understood? So we can also define the coefficient of friction as the tangent of the angle of friction. So the coefficient of friction equals the tangent of the angle of friction. Okay, this is the angle of friction. Now, so if you want to find the angle will be like this. Theta will be equals to tan inverse by mu. So here you have the angle. If you want to find the angle of friction, you can just apply this identity, that is tan inverse times mu. So I hope you understood this concept. Please wait for my next video, and I'll see you in my next video. Please subscribe, and thanks for watching.